Next up, we'd like the molecular shape of NCl3 and the electron group geometry around N. Is it polar or nonpolar? And so again, we need our valence structure, and that is going to be 5 plus 3 by 7. Our valence electrons, so that's going to be 21 plus 5, and so we have 26 electrons to play with. So let's put nitrogen as our central because it can make the most bonds. Start with 1 bond to each of the chlorines. Fill in all of our valence electrons and see if we get our 26. All of our octets, my apologies. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All of our valence electrons are accounted for. Double check on our formal charges. Chlorine, we have 7 minus 6 because of the lone pairs, minus 1 because it has 1 electron in this bond. That's going to give us 0. On the nitrogen, we'll have 5 valence electrons minus the 3 electrons in each of these bonding pairs, minus the 2 lone electrons. And that's going to give you 0, 2. So our formal charge makes sense. Our valence electrons are all accounted for. This is the correct structure. Next up, to get its geometry, we need to think about the steric number. So how many groups are attached to the nitrogen? We have 3 groups because of the 3 chlorines, and then 1 group because of this 1 lone pair. So that's going to be 4, and its notation will be AX3E1, bonding pairs, lone pairs. Go to the Vesper theory. The total number of domains are 4, and so the version of it with no lone pairs is what is going to be our electron geometry, and it just doesn't account for the fact of which ones are in bonding pairs and which ones are lone pairs. And so its electron geometry is going to be tetrahedral, but its molecular geometry will account for which ones are lone pairs and bonding pairs. And we know that we have 3 bonding pairs and 1 lone pair, so it's going to be trigonal pyramidal. Okay. And then we are asked if it is polar or nonpolar, so let's draw it out the way that the structure should look. And then let's draw our dipoles. Lone pair is always more electronegative. Chlorine, chlorine, chlorine. And so we know these 3 will add up in a specific way to give you a dipole moment facing downwards, and this one will give you a dipole moment facing upwards. It would be natural to expect them to cancel, but you need to remember that the difference in electronegativity between nitrogen and chlorine and between nitrogen and their lone pair are different. And so yes, they're in opposite directions, but they will not cancel out completely to give you a 0. It'll cancel out to give you a positive or a negative. That isn't our business right now. It just matters that it is not 0, which means that this is going to be a polar molecule. And that's it for this question.